entail, and how we'll study it. What will be the approach? What will be the thinking approach? And why are we studying it? Why do we need a mathematics course to study machine learning and AI? So, let's start with your question. What will we study in it? The first thing we'll cover is probability. Okay, good, probability. You all know the basics, but I've covered it in great detail. Then we'll move on to linear algebra and calculus. There's a lot of detail in probability itself. Like, what are independent pro-events? What is a Bayes theorem? Right? And like, independent events, and then your Bayes theorem. So what are PDFs, PMFs, etc.? And from these, we'll also discuss the Gaussian distribution and the normal distribution. This is the normal distribution. Right? Then linear algebra. In linear algebra, what is a matrix, the basics of matrix? Why is it there? Then straight lines and graph theory. Graph theory is not that kind, not discrete. That is, if things and functions are plotted on a graph, how are they done? Why are they done? So, we'll understand through straight lines, and from this, how are flat planes, etc., created. We don't need basic differential calculus or integral calculus. We'll talk about differential calculus and functions, and their differentiation, etc., which is differentiated in differential calculus. You say, there's a function x caret n, and I differentiated it. We calculated it by die dx, and the answer was nx equals 1. So why did this come about, and where did it come from when we differentiated it, and what does differentiation even mean? We'll talk about that. We'll talk about differential limits. What are limits? The basics of functions. What is a function? All of these things will be useful to you in later ML and other fields. So now the question of what we'll cover is a fairly detailed course, with a lot of things. I've just mentioned the basics. Everything will be in front of you in the playlist. Now comes the how. This how we'll study it. Our approach will be to just study the words, like we've studied the words and memorized them. Right? We won't do that. We won't memorize the words, like we'll memorize them. We'll understand the essence. We'll develop your intuition. Our goal will be to develop an intuition that I'm telling you something. Yes, this is the distance between 2 points. I derived it this way, so you should know how it came about. Right? I differentiated and got the slope. So you know that differentiating here means finding the slope, and how I'm finding the gradient, etc. So, we'll talk about all these things. Our goal will be to develop this intuition. For example, if we consider a straight line or any function, y equals mx plus c is our equation for a straight line. So, what does this equation mean? What does each term mean? And, once you develop this intuition, you'll know that if I write you a machine learning algorithm, you'll know what each term in it says. So, that's our goal, and we'll read it in the same way. And why do we need mathematics? Actually, mathematics is needed because, like I mentioned the Bayes theorem here. Let's talk about the Bayes theorem. This is the Bayes theorem. It's a machine learning algorithm based directly on it, based on life, right? It's a direct machine learning algorithm. Machine learning also has its own dedicated playlist on my channel, and it has a complete roadmap. So, give that a look. So, like the Bayes theorem, it's a direct algorithm in itself, based only on the Bayes theorem, right? But now you have to study the Bayes theorem, so you need to know what independent events are, what non-independent events are, what conditional probability is. All of those things will be covered in probabilities. Then you get to the Bayes theorem. So you study these 4 things. Then you'll go a little further. Then you'll go a little further. Like you study the 4 probabilities, conditional, independent events, etc. Then you'll understand Bayes' theorem. Once you understand Bayes' theorem, you'll understand the algorithm of Bayesian theorem. So, this is the process. That's why we study mathematics. And it's the same with linear algebra, etc. because straight lines and finding the distance between 2 points are all straightforward algorithms. For example, there's KNN, there's linear regression. Right? Linear regression. Linear regression is simply about straight lines, and if you don't understand the equation for a straight line, y equals mx plus c, what does m stand for? What does c stand for? What does x stand for? What are the things they're predicting? What is m doing in this straight line? What does c do in this straight line? Then you won't understand linear regression at all. That's how KNN calculates the distance between points. You should know all these things. If you have a graph, how do you calculate the distance between 2 points? And here, our matrix will be useful for multiplying your weights and so on. It will help you with numbers and so on. Similarly, differential calculus, limits functions, etc., are useful for figuring out your error, log loss, and all these things. If you have a machine learning algorithm, okay? If it predicts something, you need to figure out how much error it has. How far am I lagging behind? So, differential calculus helps in all of that. So, ultimately, this is a very important playlist. It has been created with a lot of hard work.